ఇటు సైడ్ పెడతావా స్క్రీన్? Okay. Good evening, everyone. This is Pawan Kumar, faculty of ESE Engineering Academy. So today we are going to discuss about some of the important questions that can be appeared or the models that has been appeared in the previous GATE examinations regarding to the environmental engineering subject. So day before yesterday we have taken a session for the preparation strategy where I have explained what are the various topics that you need to cover while preparing the environmental engineering and where you need to emphasize more and where not. Okay, so out of those important topics, I mentioned you total 20 topics. In the 20 topics, 4 topics are main: from water supply engineering, quality of water; from wastewater engineering, characteristics of seaways; and then air pollution and solid waste management. So today I'll take a topic of wastewater engineering. That topic is characteristics of seaways. In that, 90% of the questions can be obtained from one simple and very easy topic known as BOD, biochemical oxygen demand. So let's not waste our time further, and we'll get into those questions by explaining the concept first, and then I'll go for the questions. Okay. Yeah. So now first we'll discuss about the biochemical demand. What is biochemical demand? Before going to the biochemical demand, we need to know some background regarding this. Look, in the case of the wastewater engineering, our prime focus is to dispose the wastewater. But how are you going to dispose the wastewater? Means in our community, every day we generate wastewater after we get supply of the treated water. So immediately that wastewater has to be disposed out of the community. And once you dispose, you should be dumping. Majorly we dispose in whom? River bodies or water bodies, large surface water bodies, right? So but the point is how you are going to dispose that. Are you going to dispose that by treating or without treatment? You must have to dispose that by treatment itself. Look, whatever the wastewater we produce, that consists of a majorly whom? Water itself. Major amount of the wastewater is a water only. But there is a very small content in the wastewater that is known as organic matter. And that is responsible for creating lots of problems, nuisance, smell, color, odor, everything to the water bodies. And that is very, very important criteria while you are treating the wastewater. And that parameter is nothing but organic matter. So the meaning of the treatment of seaways is not about the water in that seaways, but about the organic matter in the seaways. Suppose if you dispose the untreated or raw seaways, directly into the river water body, what may happen? So whatever the seaways, that seaways consists of whom? Water, and it also consists of organic matter. Organic matter. So let's take organic matter O by M as a simple wording, and in that organic matter also there are certain type of organic matter which are going to be degraded. Organic matter means eventually that matter will undergo decomposition, and that is certain amount of the matter which is going to be decomposed by the bacteria, that is known as a bio. Bio means life. Here bacteria I say as microorganisms. Okay, so bio degradable organic matter and non-biodegradable organic matter. Okay, so if you dump a seaways which consists of organic matter, in the organic matter also the most dangerous one is a biodegradable organic matter. What is the meaning of biodegradable organic matter? the organic matter that can degrade or decompose by living things in the water, which is nothing but microorganisms. So now already in the seaways, while you are disposing from the household to the laterals to the mains and trunks, during the entire seaways, during the entire sewers, there is a slight amount of the decomposition might happen. Okay, if you don't treat that, and if you don't dispose, means if you do dispose the raw sewage directly into the river water bodies, what happen? In the fresh water bodies or large river water bodies, it will be having high amount of the oxygen. It will be having high amount of the oxygen. So when you dump the raw sewage directly into the water, now in the raw sewage, there is a organic matter, and that organic matter is a biodegradable organic matter. This will be act as a nutrient or food to the already existing microorganisms in the seaways. So in seaways, there is a food and there is a microorganisms. And there are different type of microorganisms. Certain type of microorganisms based on their survival. So there is a aerobic bacteria and there is a certain type of bacteria known as anaerobic bacteria. And especially if you see the term aerobic bacteria, that bacteria lives under the presence of the oxygen. Now, so in the seaways, there is a food, which is nothing but organic matter. And there is a microorganisms. These microorganisms can react with the organic matter chemically. But they require oxygen. Just like we require food, we require air, we require water. Similarly, bacteria require food, organic matter, and it also requires the oxygen. So when you dispose the untreated sewage directly into the river water bodies, this microorganisms starts to consume the oxygen from the water bodies. And when they consume the oxygen, and while consuming the oxygen, it starts to degrade the organic matter. So simple terms, bacteria consumes oxygen from the water body and decompose the organic matter. And in the river water bodies, if the organic matter decomposes with respect to time, it imparts color, it imparts odor, it imparts a bad taste. So that is going to create a huge nuisance, like foul smells would be coming to the surroundings. And that will be very difficult. Again, that raw water we have to treat to supply to the community, right? So it is very difficult for the water treatment plant to treat such a type of polluted waters. So what happens when you dump raw sewage? When raw sewage is disposed into water bodies, what are the things that are going to be happen? When raw sewage is disposed into the organic water bodies, what are the things it is going to be happen? So DO gets depletes. What is mean by DO? DO means dissolved oxygen. So oxygen levels in the water bodies decreases. That is going to be causes pollution to the water. Number 2, who is going to be deplete that? Microbes. Microbes consume the oxygen and decomposes the organic matter. So organic matter gets decomposes. Organic matter gets decomposes. And while decomposing, see, this is going to be decomposed by whom? Bacteria. Bacteria eats the food, they grow. And the bacterial count, pathogens count will get multifold. Pathogens is nothing but, so this is causing bacteria. This is causing microorganisms, right? So pathogens count multifold. So these are the effects that can be seen when you dump the raw sewage directly into the water bodies. So water body DO will be decreases and organic matter gets decomposes and create nuisance, odor, odor. So that is the first nuisance, odor or smell. And pathogens count multifold. So now, as an engineer, what we need to do is we have to prepare a system where you need to treat the sewage and then dispose. Our main focus of the treatment is to remove the organic matter. And in the organic matter also, the most influencing form is biodegradable organic matter. That is the one which pollutes the water more. So our point is to remove the biodegradable organic matter. But how to remove the organic matter? So, okay, in sewage there is organic matter. But how you are going to measure the organic matter? That's a big question. Organic matter is not a stabilized one. If it is a stable, it would not undergo any decomposition. As it is unstable, it will go the decomposition. When there is a decomposition, the state of the matter keep on changes. Decomposition is nothing but big one break down into small pieces, right? So organic matter is highly complex. You cannot find out that organic matter directly. Then how come I find out the organic matter, sir? You have to find out the organic matter indirectly. How? And whenever there is an organic matter, that will be eaten by whom? Bacteria. By consuming whom? Oxygen. So in the sewage, if more amount of organic matter is there, more food is there, bacteria goes and eats that food. At the same time, these microbes or bacteria require whom? Oxygen from the water. So I can say directly as whatever the amount of organic matter in the water is proportional to amount of the oxygen required by the bacteria. Which bacteria? Aerobic bacteria. So simple terms, three things: bacteria, food, oxygen. How much amount of the organic matter is present in the water can be measured by how much amount of oxygen consumed by the bacteria. More organic matter in the water, more oxygen consumed by the bacteria. So now if you see the reaction, whatever the organic matter, this organic matter, it's a very complex. It consists of carbonaceous organic matter. It consists of nitrogenous organic matter. It consists of sulfurous organic matter. Carbonaceous is nothing but carbonaceous. So whatever the carbs that we are going to eat, carbohydrates and whatever the fiber content, that all comes under the carbonaceous. Consists of carbs, fiber, starch, glucose. So those comes under carbonaceous matter. Nitrogenous matter, whatever the protein matter in the organic matter, protein content, that is a nitrogenous. Sulfurous means fats and oils, aldehydes. So apart from the carbonaceous, nitrogenous, sulfurous, there are certain type of aldehydes and acids also. So this organic matter, now it will undergoes in the presence of the oxygen. So whatever the bacteria that is there, bacteria consumes the oxygen. Bacteria consumes the oxygen and oxidize the organic matter. So there is a chemical reaction happening by means of whom? Bacteria. Bacteria is a living thing, bio. And there is a chemical reaction happening with the organic matter, biochemical reaction. How it is happening? In the presence of whom? Oxygen. Suppose if there is no oxygen, no oxygen, will there be any chemical reaction happens? No. Just bacteria and food doesn't happen. Bacteria has to consume oxygen first. Which bacteria, sir? Aerobic bacteria. So now, whatever this oxygen consumed by the aerobic bacteria, this aerobic bacteria consume oxygen and decomposes the organic matter. And finally, it produces stable end products. Stable end products like carbon dioxide plus ammonia plus sulfates. So ammonia and nitrates also. So NO3 minus, okay. So nitrates, sulfates, ammonia, these are the end products. Along with this, it is going to be releases some amount of the energy plus growth of microbes or bacteria. So this aerobic bacteria does this chemical reaction and produces these are the end products. Now, how I am going to find out this organic matter is, I don't find it directly. Simply, this require this much amount of the oxygen. More the organic matter, more the amount of oxygen consumed by the bacteria. In other words, the organic matter is going to be evaluated by measuring the amount of oxygen consumed by the aerobic bacteria. So, aerobic bacteria consumes oxygen and decompose organic matter. And that too, which organic matter? Biodegradable organic matter. So this is nothing but biodegradable. And whatever the amount of oxygen aerobic bacteria consumed, that is known as BOD. So this is nothing but the BOD. So what is BOD? What is BOD? The BOD is nothing but the amount of oxygen consumed by whom? Aerobic bacteria to decompose whom? Organic matter. So the more the amount of the BOD required by the bacteria, the more the amount of organic matter, right? So amount of organic matter is proportional to O2 consumption of bacteria. So with this concept, we are going to enter into the BOD. So what is a BOD? Now, now, what is a BOD? So there comes the definition of the BOD. BOD definition. BOD means amount of oxygen consumed by aerobic bacteria to decompose biodegradable organic matter. So more amount of the BOD, more amount of the organic matter. Now if I find out that BOD, that itself will help me to find out the organic matter. So let's see how to find out this BOD. Generally, polluted waters undergo months and months of time to decompose fully organic matter. So generally, polluted waters takes months of time to decompose the organic matter fully. 100% of decomposition is not practically possible. Practically, it is highly impossible. You will get to know. So 100% of the pollution, 100% of the organic matter will not get decomposed. Even if it decomposes, it takes very, very long time. So we don't have that much time. What we can do is, out of this organic matter, the most easily decomposable organic matter is carbonaceous organic matter. So if you see the graph with respect to the time and organic matter, so time T, and this is nothing but O2 consumption, which is nothing but BOD. O2 consumption, which is nothing but BOD. So now initially when time T is equals to 0, time 0, There is organic matter in the water and there is a bacteria. Now, this aerobic bacteria consumes whom? Oxygen, and decomposes the organic matter. So, with the time, bacteria consumes oxygen. So, consumes oxygen and decomposes organic matter. And consumes oxygen and decomposes organic matter. So, now if you see this graph, this shows that with the time, the consumption of oxygen is increasing. When the bacteria is consuming, it is decomposing the organic matter. And the first form of organic matter that decomposes is a carbonaceous organic demand. What is the meaning of carbonaceous organic demand? Carbonaceous organic demand means oxygen demand, sorry. The carbonaceous oxygen demand means this much amount of oxygen consumed by the microbes to decompose the carbonaceous matter. And then after this, you can see the nitrogenous and then you can see the sulfurous. Whatever this is nothing but sulfurous, nitrogenous oxygen demand. Nitrogenous oxygen demand. But for all practical purpose, by the time this carbonaceous oxygen demand occurs, it is going to be take around 30 to 40 days. I don't want to waste that much amount of the time. And in organic matter, major component is also carbonaceous demand only, carbonaceous organic matter. So, I will not go for all the forms, I will go for only the carbonaceous oxygen demand. So, this is nothing but first stage of decomposition. First stage of decomposition. So, what I am going to do over here is, instead of looking the total organic matter, I will be seeing the major component which is nothing but carbonaceous. And how much amount of oxygen required for the decomposition of carbonaceous matter, that is known as carbonaceous oxygen demand, and we are going to consider that as a BOD. So, practically BOD is nothing but oxygen demand for the carbonaceous matter. Practically, BOD refers to O2 consumption of carbonaceous matter. So, now carbonaceous matter, I will be seeing only this one. So, with the help of this, now let's see how to find out the BOD. Let's see how to find out the BOD by means of a BOD expression. So, this is the background that I want to suggest you. Now, let's see how to find out the BOD. So, that is by means of the BOD expression. So, if you see the BOD expression, in the case of the BOD expression, so what we are going to learn here is amount of organic matter depletes or amount of oxygen O2 consumption is proportional to organic time. So, we take generally the time in terms of days, and on y-axis we take it as organic matter, which is nothing but nutrients, right? And take one more graph. So, this is a time in terms of days, and here oxygen consumption, which is nothing but BOD. Mind you, whatever the BOD that we refers to, that is only for the carbonaceous oxygen demand, not for the total oxygen demand. We are dealing only carbonaceous matter. Okay. Now, if you see, when time t is equals to 0, when time t is equals to 0, in water there is organic matter, but there was no decomposition. So, let's say the maximum amount of the organic matter, let me represent with the L0. What is meant by L0? total amount of organic matter in the seaways when time t is equals to 0. So now this also implies that arey bhai, if this is a total amount of organic matter, then that much amount of organic matter has to deplete or not? Yes. If this is the total amount of organic matter, it has to deplete. When it has to deplete, then how much amount of organic matter depletes, that much amount of oxygen consumption is going to be happen, right? Who? Oxygen consumption by the bacteria. So what is BOD? Amount of oxygen consumed or utilized by the bacteria. If the bacteria wants to decompose this much amount of organic matter, what is the amount of oxygen it requires? That much amount only. That we are going to call it as ultimate BOD. Ultimate BOD. So whatever the cell utilizes oxygen. So when oxygen increases, organic matter will get depletes. And are they deplete by means of the constant rate? Are they deplete by linear or non-linear? Non-linearly. Exponentially they will decay. Exponentially they will decay. And that decay will follow first order decay. And if you see, how does that first order decay looks like? Now you see here, from here onwards, the organic matter will get deplete. How come the organic matter deplete? By oxygen, when the bacteria utilizes the oxygen. So now at any time t, suppose if I ask you at any time t, how much amount of organic matter present in the water is, whatever, this is nothing but the organic matter available in the water at that time t. And how much amount of organic matter depleted? This is L0 minus LT. That is L0 minus LT. That much amount of organic matter got depleted. How this organic matter got depleted? By bacteria consuming oxygen. Array, this much amount of organic matter depletes means that much amount of oxygen will be consumed or not. And that is going to be represented at that time. That is going to be represented as a YT. Here Y represents the BOD. Here Y represents the BOD. Now with the time, this organic matter decays, goes on. With the time, the utilization of or consumption of oxygen will increases. Now you see, these graphs are going to be reaches asymptotical to the axis. They are not touching the x-axis. They are not touching the ultimate BOD. Why, sir? Because 100% of organic matter cannot be removed. It takes, theoretically it is not, practically it is not going to be possible. So in simple terms, I'll use this one, amount of oxygen consumption. How much amount of oxygen consumed? That is nothing but YT. So what is YT? BOD. Oxygen consumed by bacteria in T days. For that, how much amount of organic matter depleted? L0 minus. Oxygen is still present in the system. This is the ultimate. Then how much amount of the organic matter is still present in the system? This value. And this value is simply represents the amount of organic matter in the system or not. If this much amount of organic matter is there, still that much amount of oxygen is required. So how much amount of the BOD remained in the system? This is nothing but BOD remained. And this is nothing but BOD exerted or utilized or consumed or removed. How much BOD oxygen removed from the system, utilized from the system, consumed by the system is YT. Remained is this value. Now from this graph, I can simply say that I hope you understood this, what is the relation between the organic matter and the BOD. And from this, we can say, let's say the terms L0 total amount of organic matter in seaways. okay, and which is nothing but L naught is equals to ultimate, which is also equals to total oxygen required by microorganisms. So I can write ultimate BOD is equals to L naught. And now you see, if LT is amount of organic matter at time t, so the decay of organic matter follows as percentage decay percentage rate of decay is constant. Percentage rate of decay is going to be the constant. So now what is the meaning of percentage rate of decay, sir? Percentage DL, decay, by L at any time by per unit time dt is assumed as a constant, some k. But as you're dealing with the decay, you're going to write as a minus. The minus represents a decay. So now you can write dl by lt minus k into dt. If you integrate from initial, so at any time L naught to LT, so I can represent this one as directly L instead of L. So what is L? The L is nothing but the organic matter. And I can integrate from 0 to T. If you do so, after integration, then you are going to get down that LT is equals to L naught into e to the power of minus K into T. And this is depends upon the time. So I'll write down this K in terms of T. So what is this LT? The LT is nothing but amount of organic matter at a time T. What is LT? LT is nothing but amount of organic matter at a time T. Okay. But what I want is BOD, right? I don't want how much organic matter is left in the system. I want how much oxygen utilized by the system. System means bacteria. So how much organic matter, or sorry, how much amount of oxygen utilized is nothing but L naught minus LT. Now, by saying from this equation, amount of oxygen utilized or consumed or exerted in T days is equals to YT. Amount of oxygen utilized or consumed or exerted in T days is nothing but YT. And how to find out this YT? How much amount of organic matter that has left from the system or removed from the system. So how much amount of organic matter removed? L naught minus LT. Now if you substitute that LT over there, then YT is equals to L naught minus LT. So L naught minus L naught into e to the power of minus KT into T. So YT is equals to L naught into 1 minus e to the power of minus KT into T. This is the BOD expression. So what is mean by YT here? What is the meaning of YT? The meaning of YT is amount of oxygen consumed by the microbes in how many days? In T days. Amount of oxygen utilized or consumed by whom? Microbes in T days. So for 2 days, how much? For 3 days, how much? For 4 days, how much? And that depends upon the ultimate BOD into 1 minus e to the power of minus K into T, where KT is nothing but reaction rate constant. that depends on temperature. Reaction rate constant that depends upon the temperature. Sir, how to find out this reaction rate constant? Generally, see, whatever the BOD expression BOD test that was developed in that country, the standard temperature is 20 degrees centigrade. Their standard temperature is 20 degrees centigrade. So whatever this KT is, the standard 20 degrees centigrade, the T is nothing but temperature. T is nothing but temperature into theta whole to the power of T minus 20. So where the theta is known as a temperature coefficient. Temperature coefficient. So what is the temperature coefficient? Generally, theta is taken as 1.047. So for all the temperatures greater than 20 degrees centigrade, so generally we take it as a 1.047. Sometimes in examination, they may give you some other value, but if they use a term known as a temperature coefficient, that is a theta. What is theta? 1.047. Maximum they will mention. If they don't mention, directly you can take it as 1.047. If they do mention some other value, then you consider that value. There was a previous GATE question where they have mentioned the temperature coefficient as 1.135. Then you don't take theta as 1.047. You have to take the theta as 1.135. So what is the theta? The theta is nothing but temperature coefficient. And T, capital T, is nothing but temperature in degrees centigrade. And what about that small t? That is nothing but time of exertion or utilization in days. So eventually that KT is equals to K20 degrees into theta power T minus 20. Now this K20 degrees is there, right? That is a constant value. This K20 degrees centigrade is so 0.23 per day in a given day. This is base E. If you use the natural logarithm, so you see here, whatever this is nothing but E, this equation can also be written as in terms of 10 power. This also can be written as Yt is equals to L0 into 1 minus 10 to the power of minus Kt into T. Okay, minus Kt, 10 to the power of minus, but this is what is the power? 10 powers. So if the base is E, then you have to take it as 0.23 per day. And if the base is going to be 10, then you have to take it as 0.1 per day. This is base 10. In examination, they will clearly mention whether to use base 10 or base E. Base E, natural logarithm, base 10, 10 powers. So they will clearly mention based on that. If I would have given the base E, then you have to take that value as a base E, and in equation it should be E power. And if the base 10, that is going to be 0.1 per day, that is going to be the K20 degrees centigrade. Okay, and with this, so we got to know how much amount of BOD utilized in a given time. Now the general form of BOD is Y at T whole to the power of T. So what is the meaning of T? At a temperature T degrees centigrade, amount of oxygen consumed by bacteria in T days. Now you see in the graph itself, in the earlier time more amount of the oxygen is consumed. Generally in our laboratory we go for a test. In laboratory we go for a test. BOD is measured. Ultimate BOD is not measured because it takes very long time. So For example, at 20 degrees centigrade in 5 days, how much amount of the BOD is going to be utilized? At a 20 degrees centigrade in 5 days, then y to the power of, means y5, 20 degrees centigrade is equals to L0 into 1 minus e to the power of minus k into 20 into 5 days, right? Right. That's a KT, which becomes 20 degrees, right? And time is 5 days. Now if you substitute 1 minus e to the power of, I told you K20 minus 0.23 into 5, then 5-day BOD at 20 degrees centigrade will become 0.684 L0. What is the meaning of 0.684 L0? What is the meaning of this? Now, go back to this term. So at temperature, T degrees, at a temperature 20 degrees centigrade, amount of oxygen utilized by the microbes is 68.4% of the ultimate in 5 days. In 5 days, at 20 degrees centigrade, how much oxygen is utilizing? 68.4%. So as majority of the oxygen it utilizing in just 5 days, we are going to do the test in the laboratory as a 5-day BOD test. And how to find out the 5-day BOD test, that you know it very well. So I'm not going to discuss about the 5-day BOD test over here. So my point is about the BOD expression. I want to explain that, which gives entire criteria. Now, why we do 5-day BOD test is 70%, around 70% of the organic matter is depleting here itself. Then why to wait for 20 days or 30 days? So in lab, we conduct 5-day BOD test. So how to conduct the 5-day BOD test? After doing that, from the lab, you know how to find out the 5-day BOD test. 5-day, 20 degrees centigrade. That is, so whatever the initial DO of the diluted sample by minus final DO of the diluted sample into dilution factor. So DOI means initial DO of the diluted sample. So initially you take raw water sample and you are going to mix with the distilled water to total volume of 300 ml. To total volume of 300 ml. After dilution, immediately the DO, and you incubate at a 20 degrees centigrade for 5 days. So the microorganisms utilize the temperature, utilize the oxygen, and incubates, ferments. Finally, the DO will get depleted. So that dilution factor, is nothing but 300 by volume of the undiluted sewage sample, or 100 by percentage of dilution. Anything is fine. In lab, you don't find out the ultimate BOD. You find out 5-day 20 degrees BOD. And once you find out the 5-day 20 degrees BOD, then you can find out the ultimate BOD by using the BOD expression. What is the BOD expression, YT? Sir, so which means in time 5 days, this much amount of oxygen is consumed. Then how much amount of oxygen is left or remained? The amount of oxygen left or remained, that is BOD remained, which is known as LT. So just like how I mentioned, amount of oxygen utilized is L0 minus LT. Now, amount of oxygen or BOD remained is equals to LT. So, BOD remained is, this is nothing but LT, which is L0 into e to the power of minus KT into T. That K value is nothing but reaction rate that depends upon the temperature, my dear. When temperature is going to be increases, you see, the more the temperature, the more the K value. Means the reaction happens at faster rate. So the decomposition happens at faster rate. But ultimately, the maximum BOD will not change. That is remain same. But to reach that point, the time is going to be changes. So this is the concept. Now, based on this concept, let's solve some of the numericals. So this is a complete explanation of BOD expression and how to determine the BOD and what is BOD and all. Now, If you see some of the questions, so now I think today, due to the India-Pakistan match, as of the students are focusing towards majorly for the match, not for the subject. Fine, let's say. Now coming to this question, this was the previous gate questions that I was discussing over here. Okay, a student began experiment for determination of the 5-day 20 degrees BOD on Monday. So 5-day BOD he wants to find out, but since the 5th day fell on the Saturday, the final DO readings were taken on the next Monday. So next Monday means 7 days. Therefore, 7 days 20 degrees was found to be 150 mg per liter. Is it 5-day BOD or 7-day BOD? 7. At a standard temperature of 20 degrees as 0.23 per day, and they clearly mention that use base E. So what they have given is, in this question, what they mentioned is 5-day in this question. So what they mentioned is seven-day BOD at 20 degrees centigrade is given as 150 mg per liter. But what I want is 5-day BOD at 20 degrees centigrade. So this is my question. And what I can do is, I'll go with the standard way. Y at T days and T degrees centigrade is equals to L naught, this is the BOD expression, right? Into 1 minus e to the power of minus KT into T. So in both the cases, L naught is same, right? So what I do is, I'll write what I want is 5-day 20 degrees BOD, so divided by 7-day 20 degrees BOD is equals to L naught into 1 minus e to the power of, the temperature is 20 degrees only, so the given K 20 degrees centigrade is directly mentioned as 0.23 per day. And mind you, that is about whom? E to the power of. So they have given clearly mentioned, about the base E. So as it is a base E, e to the power of minus 0.23 into how many days? 5 days. By L naught into 1 minus e to the power of minus 0.23 into how many days? 7 days. So L naught will get cancelled. I want 5-day BOD at 20 degrees centigrade. What I got is 150 is equals to this value you need to calculate. So the numerator comes as 0.683 by denominator denominator comes as 0.80. So finally the 5-day BOD at 20 degrees centigrade is equals to 128.04 mg per liter. So whenever they give one form of BOD and they will ask other form of BOD some other days, then you simply go with the ratio, then you are going to get the answer. The answer is 128.04. So it was a GATE 2013 question. Now hope you understood. The answer is going to be 128.04. So this is the way that you need to solve this question. Okay. Now let's see one more question. You see here, ultimate BOD of a river water is given as 20 mg per liter. What is ultimate BOD? Ultimate BOD is nothing but L naught. The BOD rate constant natural log, so natural log means E, is 0.15 per day. So they have given the BOD rate constant. So K value is given as 0.15 per day, KT. And respective values of BOD exerted and remaining after 7 days. So how many days they are mentioning? 7 days. So for 7 days, how much amount of BOD utilized and how much of BOD remained? So L0 is 20 mg per liter. They are asking in terms of percentages, right? So first of all, how much amount of the BOD utilized in 7 days? So standard is nothing but 20 degrees centigrade. This is going to be L0 into 1 minus e to the power of minus K20 into how many days? 7 days. So if you see the 7 days, then what is L0 given? The L0 given is 20 mg per liter into 1 minus e to the power of minus 0.15 into 7 days. If you find out, that is going to be around 13 mg per liter. So what is the meaning of this 13 mg per liter? In 7 days, BOD consumed or exerted. BOD consumed or exerted is nothing but 13 mg per liter. So now if you see, out of the 13 mg per liter has been utilized. Then percentage of BOD exerted is 13 mg by 20 into 100. That much utilized, right? Then this is going to be 65%. If BOD utilized is 65%, then BOD remained. So percentage of BOD remained is equals to 100 minus 65, which is equals to 35%. 35%. So the correct answer is 65% and 35%. Okay. So that's about the question number 2. And you see, this was asked in a GATE 2018 set 1. The ultimate BOD L0 of wastewater sample is estimated as 87% of the COD. So instead of giving the BOD, they were saying that 87% of the COD. You know what is meant by COD? Chemical oxygen demand. That is the oxygen required to oxidize complete organic matter. So in BOD, we discuss only biodegradable. But in COD, biodegradable plus non-biodegradable. Obviously, always, so COD is greater than or equals to BOD, right? So the COD of this wastewater is given as 300 mg per liter. Then from this, then what is ultimate BOD? 87% of 300. So that value goes as 261 mg per liter of the ultimate BOD. That much amount of oxygen required or consumed by the microbes. Now, considering the first order BOD reaction rate constant, use natural log. Again, natural log means E. And temperature coefficient, see they have given the temperature coefficient theta 1.407. The BOD value up to 1 decimal after 3 days of incubation. So how much amount will be consumed in 3 days? At what temperature? 27 degrees centigrade. So now the question I am asking is, I want to find out how much amount of BOD utilized in 3 days at 27 degrees centigrade. So that is going to be expression L0 into 1 minus e to the power of minus, this time it's not 20, it is 27 degrees centigrade into how many days? How many days I am going to use? That is going to be the 3 days, right? First of all, you need to find out the K 27 degrees centigrade, which is K20 into, what is the theta? T minus, so Kt is equals to K20 into theta power T minus 20. And they have clearly mentioned the temperature coefficient. So now K27 degrees centigrade is equals to K20. What is the K20 value? That given as 0.23 per day. 0.23 into 1.047 whole to the power of 27 minus 20. So what is this value? (1.047 power 7 into 0.23). So this value goes as 0.317 per day. So now you see, you have to understand 20 degrees, that is 0.23. But now for 27 degrees, how much reaction is happening? 0.317. So reaction rate increase. So BOD utilization can be happen quickly, right? So now substitute over there. So Y 3-day 27 degree BOD is equals to, what is L naught? 261 into 1 minus e to the power of minus 0.317. For how many days I am asking? 3 days. Find it out. Minus 0.317 into 3 days into 261. So the answer goes as 160.16 mg per liter. So in 3 days at 27 degrees centigrade, the BOD consumption is 160. Oxygen consumption is 160.16 mg per liter. So these are the some of the models that has been appeared in the previous gate, and with one last question I'll be winding this session. So this is a very good question where they have mixed the points. A stream with a flow rate of a stream means river, with a flow rate of 5 meter cube per second is having ultimate BOD in the case of the river is 30 mg per liter. Now a wastewater discharge, so this is the sewage discharge QS, let's say, having BOD, this is not ultimate BOD, this is a 5-day BOD. This is a 5-day BOD, 500 mg per liter, joins the stream at a location. So now this is a river is coming, and in the case of the river, so it is having some QR, it is having some ultimate BOD, it is having some ultimate BOD. So ultimate BOD of a river, okay, and where we are going to add, so at this point, this is a point of disposal, we are adding sewage. So it is having some QS, and they have given the 5-day BOD. So they have been mixed instantaneously. Now if I write down the data goes as river QR is 5 meter cube per second, ultimate BOD of R is 30 mg per liter. Obviously in river it is less. Q, river does not have much of the pollution, organic matter would be less. Whereas the stream of wastewater, which is nothing but sewage, so its flow rate is very small, 0.2 meter cube per second, but they have given the 5-day BOD as 500 mg per liter. Mind you, this is not ultimate BOD, that's a 5-day BOD. And they have mixed instantaneously, So when they mix, then the ultimate BOD of the mixture will be different, right? So it has different ultimate BOD, L naught of S, that is a different, and it has a different ultimate BOD. When they mix together, after mixing, immediately the ultimate BOD changes, right? So now what is the question they are asking? The cross-section area of the stream area is given as 40 meters square, which remains constant. BOD exertion rate they are also given, that's a logarithmic base to E. So K value is also given 0.3 per day, K at a certain temperature. The BOD round off remaining at the 3 kilometers downstream from the mixing location. What they are asking is how much amount of BOD remained at 3 kilometers downstream from the mixing location. They are not asking how much BOD consumed, they are asking how much BOD remained. So now at a 3 kilometers distance, what is the amount of BOD remained? First of all, we need to find out when they mix, what is the ultimate BOD. If I know the ultimate BOD, then I can find out how much amount of the BOD remained at a distance of 3 kilometers. So now let's see. First of all, you find out for Seaways, what is ultimate BOD? For Seaways, what they have given is 5-day BOD, and they have given the K value. So that K value, you know, what is this value they have given? Certain temperature, right? Is equals to L0 into 1 minus e to the power of minus K into 5 for Seaways. So what is the 500 is equals to L0 into 1 minus e to the power of minus 0.3 into 5. So you will get down the L0. What is this L0 value? This comes under 643.61 mg per liter. This is the L0 in the case of the Seaways. Now, ultimate BOD in the Seaways is 643.61. Ultimate BOD in the river is 30 mg per liter. Then after mixing, what is the ultimate BOD? So, ultimate BOD of the mix, that is a weighted average. So, river stream rate into ultimate BOD of the river plus Seaways stream rate into ultimate BOD of the Seaways by total QR plus QS. Right. So now, if you substitute over here, so you're going to get down 5 into 30 plus 0.2 into 643.61 by 5 plus 0.2. So get down this value. So 0.2 into 643.61 plus 15 into 5 into 30, which is nothing but 150 by 5.2. This comes as 53.6 mg per liter. So what is the meaning of this? After mixing instantaneously, at this point the ultimate BOD is 53.6 mg per liter. Now, over a distance of 3 kilometers, definitely that ultimate BOD, so as it is a river body, it has a good amount of oxygen. Bacteria consume the oxygen and it is going to be depletes the organic matter. So that much amount of organic matter will get depleted, right? How much amount of the BOD left at this point is? So at a 3 kilometers distance, how much amount of the BOD left? BOD remained is nothing but LT is equals to L0 of that mix into e to the power of minus K into T. Now, everybody, I want LT. I have a lot of mix, I have K, but how to find out the T, time? Don't you think to water to move from here to here, it will take certain time T. How to find out that time T? I know the total flow rate coming. So now, what is the total flow rate? The total flow rate is QR plus QS, which is 5 plus 0.2, 5.2 meter cube per second. That much amount of the flow rate is coming, and they have given the cross-section area. Once they give the cross-section area, can't you find out the velocity? Yes. So with that velocity, this mix is flowing over a distance of how much? 3 kilometers. Can't you find out the time? Yes. Now, first you find out the velocity, which is a Q by A, which is 5.2 by 40. 5.2 by 40. So this is 0.13 meter per second. That with that velocity, the water is moving. How many kilometers it has to travel? 3 kilometers. Then you know velocity is nothing but length by time. Then from that 3 kilometers is nothing but 3 into 10 to the power of 3 meters by 0.13. 3 into 10 to the power of 3 by 0.13. This gives us 23,076.92 seconds. But convert that in terms of days, because here the t must be in terms of whom? Days. So divide with 24 into 60 into 60. That gives 0.267 days. Now, what is the meaning of this one is, after mixing 5.2 meter cube per second of the flow rate is flowing with a velocity of 0.13, and to travel 3 kilometers distance, the time required is 0.267. So it required 0.267 days, and in this 0.267 days, some amount of BOD exerted, some will be remained. I am asking you remained. So now what is that remained value? The remained value is, now if you find it out, the remained value is LT is equals to 53.6 into e to the power of minus 0. What is the value? 3 into how many days? The days is 0.267. 0.267. So this is going to be the value. So you will get as 49.47 mg per liter of BOD still present in the water. So the question they are asking, you have to be very careful. Are they asking remaining or are they asking exerted? So after mixing, what is the BOD that you are going to get is 53.6. Out of that, over that distance, it is going to be utilized as very, very few, and finally it is remaining as 49.47 mg per liter. So these are various type of questions that has been appeared based on the BOD expression. See here, I am not discussing about how to determine the 5-day BOD lab test. I am discussing about if they give the data, how to find out the BOD expression, what are the various type of models. So these are 4 models, different models, which explains the BOD expression. So I hope this session has helpful for you. So where I explained the concept clearly when the stipulated time, where I discussed almost all the major points where they can be asked in the examination. So thank you for the session, and hope it gives much more understanding towards the BOD expression and BOD. So all the best for your examination. Take care.